Good morning, everyone. I'm Yifan Wang from Group 7, and today I will be talking about three key types of retaining wall systems used in basement construction: diaphragm walls, second pile walls, and contiguous pile walls. I will explain their construction methodology, appropriate ground conditions, and where each system is best applied. Let's start with construction methodology of diaphragm walls. These are reinforced concrete walls constructed by excavating narrow trenches in the ground and then install steel reinforcement. At last, refilling them with concrete using a stop-end method and temporary bend-knee slurry supports. The methodology is best suited to a top-down construction sequence, where basement floors and the superstructure are built simultaneously. This helps speed up the construction of tall buildings in urban areas. In terms of performance, diaphragm walls often offer excellent water tightness, structural strength, and are ideal for very deep basements, often exceeding 25 meters. Next are second pile walls. These are formed by drilling and interlocking a sequence of hard and soft piles, with some overlap to form a contiguous wall. They are often used in bottom-up construction method, meaning the basement is fully excavated first before construction begins upwards. Compared to diaphragm walls, second pile walls are a bit more flexible in shape and require less set space, making them useful in entire city sets. They provide moderate water resistance and are suitable for medium-depth basements, around 50 to 20 meters. Now, let's talk about the contiguous pile wall. This is the simplest and cheapest method. It involves drilling closely spaced piles, but unlike second piles, there is no overlap, just a small gap between each pile. It is built using a bottom-up method, and because of its poor water control, it is usually reserved for temporary excavations or basements in dry ground conditions. Now regarding ground conditions, diaphragm walls require ground that can remain stable temporarily during excavation, often supported by bent-knee slurry. They are more suited to steep clays, dense sand, or lighter soils with groundwater, but less ideal in very soft, collapsing soils or very hard rock due to excavation difficulty. The ideal ground conditions for second piles introduce cohesive soils like clays or silts that can support in the drilling of overlapping piles. They can handle some of groundwater, but aren't completely watertight. So some form of internal lining may still be necessary for full dry basements. The ground conditions for contiguous pile walls may reasonably dry and stable, such as dense sand or firm clay, with minimal groundwater presence. If there's too much water pressure or the soil is too soft, the gap between the piles can let the water in or even cause collapse. Despite these limitations, it's commonly used where budget is tight and water control isn't a crucial concern, like temporary retaining wall during infrastructure work. To summarize, diaphragm walls are your go-to for deep, permanent basements with strict water control, especially in urban high-rise construction. Second piles are a great mid-range solution, easier to install, good for moderate depths, and suitable in semi-watertight soils. Contiguous pile walls are the most cost-effective, used in dry, stable soils for short-term support or shallow basements. Choosing the right method depends on many factors: depth, water table, and soil type, budget, and program. As engineers, it's our responsibility to balance all this to deliver safe, efficient, and economical designs. Thank you for your attention. I'm happy to answer any questions about these wall systems or their construction techniques. Let's welcome Zhihao to introduce the next part.